Good day, guys. Let's look at arc length, this time for Math N6 that concerns parametric equations. So we're told to calculate the arc length of the curve described parametrically as x equal to 5 in bracket cos t plus t sin t and y equal to 5 in bracket sin t minus t cos t between t equal to 0 and t equal to pi. So when it comes to parametric equations, the limits do not really tell you anything. You just need to go to page 6 and look for the formula that it's talking about the dx and dy in the same equation. So my formula on page 7, not page 6, guys, is the integral from t1 to t2. So in your formula sheet, you will see u1 to u2 because the formula sheet is using the variable u. Then you have dx over dt, all that square, where the formula sheet will be having du there, plus dy over dt, all that square. Then I end with dt, which in the formula sheet it will be du. So that's the formula that you will pick up whenever your problem involves parametric equations from page 7 of your formula sheet. So each time you get the correct formula, it then guides you through everything. So this formula says I must differentiate x with respect to t, square it, then also differentiate y with respect to t, square it, then add the two together, simplify before I bring to the square root, making sure that what I bring there, the square root can manage. So let's start with our x. So our x is given as 5. I prefer to use a square bracket this time, into cos t plus t sin t. So that is what we have. So we go on and look for dx over dt. So we have dx over dt being equal to 5. That is a constant. You capture it exactly the way you see it and only concentrate on items that have got the variable to differentiate. So if I differentiate cos t, that gives me negative sin t plus. Then if I get to that 1, to this next term, you must not forget that this is a product of a linear term and a trigonometric term. When we are differentiating a product all the times, we want to use product rule. So you can choose one as u, the other one is v, so that you use the formula u v prime plus v u prime to go through that. So if I use that here, it means my u will be a t. V prime means I differentiate sine. If I differentiate sine, it gives me cos t, then plus. If I now go, I'm done with u v prime, that is my u v prime is there. If I now go to v, my v is sine t. Then if I differentiate u, it means I'm differentiating t. It gives me 1. So looking at that very well inside your bracket, you see that sin t will take care of negative sin t, and you are left with 5t cos t. So our dx over dt is simply 5t cos t. Then I can now move on and do the squaring. If I square that my derivative, I will get the square of 5t cos t, and that should give me 25t squared cos square t. So you can see that I'm done with the first part of my formula. I can now switch over to the second part, which is now talking about y. So in the second part, we've got y equal to 5. I will again prefer square bracket since I have to do a product inside. Sin t minus t cos t. So that's my y. So let's look for dy dt. So dy dt is 5 in bracket. If I differentiate sin t, it gives me cos t, then minus. If I get to this one again, that is a product. So each time I'm differentiating a product, I must be seen using the product rule. So this will again be my u, that will be my v. So I will go through u v prime. And now that there is a negative signs are very dangerous. so you have to put a bracket to avoid getting into trouble. So I'll look for u v prime. My u is t, v prime means I differentiate cos t. If I differentiate cos t, it gives me negative sine t, then plus, the plus now is this one, then I go to v, my v is cos t multiplied by u prime means I'm now differentiating t to get 1. So if you now open through your bracket to check what is your dy dt, you will see that when you open the bracket, let's open the inner one first to have a proper view of what is happening. This negative and this one become a positive, so you get plus t sine t, then this negative goes there to give you a negative cos t. So you see that cos t will take care of sine t, and you're having your 5t sine t as your dy over dt. So if you now move on and do the squaring, dy over dt, or this square will be 5t sine t, all that square, and that gives us 25t square sine square t. So now we are done with those two parts under our square root. We can then pull them together with a positive sign, as the formula is saying. So if I get dx over dt, all that squared, plus dy over dt, all that squared, that means I'm taking this answer plus this one, so I'm getting 25t squared cos square t plus 25t squared sine square t. So that's what I'm getting. And you see that 25t squared is a common factor. So you get you take out your common factor, you get cos square t plus sine square t. That is equal to 1. Cos square plus sine square is equal to 1. For mathematics student, that is the first formula on page 1 of your formula sheet. So we're left with 25t squared. We can now start integration because we have managed to handle the item under the square root. So our t1, 0, our t2 will be pi, so we get 0 to pi, the square root of 25t squared t, and when you take the square root of 25, it gives you a 5, that is a constant. I place it out, the square root of t squared is t, and if you integrate t, you get 5t squared over 2 from 0 to pi. Then you can substitute your limit. If I substitute my limit, starting with the upper one, I'll get 5 pi squared over 2 minus 5 into 0 squared over 2. So the second, the lower limit gives me a 0, and my answer is simply 5 pi squared over 2, which you can leave it like that, or if you choose to use a calculator, you will see how it looks. So I get 5 times pi squared on 2. That gives me 24,674. So I get 24,674 units. So guys, that's how to get the arc length of an equation that is described parametrically. So thank you very much.